Today we're going to continue our study of Chapter 6 with Lesson 3, Global Winds and Local Winds. We have 3 objectives for today's lesson. You should be able to do the following: explain the relationship between air pressure and wind direction, describe global wind patterns, and explain the causes of local wind patterns. You're going to go back and watch the study jam on air pressure and wind. Okay, let's talk about pressure belts for just a second. You can see that, of course, this is the equator, so 0 degrees latitude, and then we have both 30 degrees north and 30 degrees south, 60 degrees north, 60 degrees south, and then 90 degrees north and 90 degrees south. So with each one of these, you start out with a certain type of pressure and then it alternates. So if you'll look at 0 degrees at the equator, you have low pressure. At 60 degrees north and south, you have low pressure again. So in between that, you have high pressure. So 30 degrees south, 30 degrees north. So And you'll also see over to the side, you've got cool air sinking and warm air rising within each one of these. So from 0 degrees to 30 degrees north latitude, from your low to your high pressure. This is what is causing this to happen. It's due to the sinking of the cool air and the rising of the warm air. So this is why air moves. Air rises at the equator and it sinks at the poles. So we know as cold air sinks, it creates areas of high pressure around the poles. And you can see that in the picture. We started at low, then high, then low, and then high. Same way with the south. So this cold polar air then flows toward the equator. And just as we discussed, there are pressure belts that are found at every 30 degrees. So 0, 30, 60, 90, both north and south. Convection cells, remember convection? Think of it as a circle, rising, falling. They are separated by pressure belts, which are bands of high and low pressure. So this constant movement of air is what causes these pressure belts to exist. So your high pressure and your low pressure. A lot of this has to do with the Coriolis effect, which we've discussed before. So we know that the Earth rotates on its axis, and there's this apparent curving of the path of currents due to Earth's rotation, and that is called the Coriolis effect. So you can see the path of wind. If we did not have the Coriolis effect, it would be straight up and straight down. And the approximate path of the wind is in these purple lines due to the Coriolis effect. So let's talk a little bit about global winds. So we have different kinds, or they're called different things, of global winds. So let's just take a look at each one of those really quickly. So of course the blue is cool, the red is warm, and these purple lines here indicate the wind direction. And notice they're kind of opposite in each. So let's start again at 0 degrees equator. You have what are called the doldrums. And I kind of think of those as doldrums because basically there's no wind. It's kind of dull. So doldrums, think doldrums. At 30 degrees north and south latitude, you have what's called the horse latitudes. I encourage you to read in your textbook the story that goes to why those are called horse latitudes. So please look that up because it's kind of interesting. Kind of sad, but kind of interesting. And then at 60 degrees north and south, which is between your 60 and your 90, would be your polar easterlies. Okay, and notice they're both going from the east. So they're called easterlies. So since we just talked about the easterlies, look, these are coming from the west. So in between 30 and 60 degrees, north and south, you have the prevailing westerlies. So the polar easterlies, prevailing westerlies. And then between your 0 degrees, your equator, and your 30 degrees north and south, you have the trade winds. Okay, so moving around, starting with the equator, the doldrums. Hardly any wind. It's just kind of dull. 30 degrees north, 30 degrees south, horse latitudes. And then your polar easterlies, your prevailing westerlies, and your trade winds. So let's go back to this. So again, your polar easterlies, the wind belts that extend from the poles to 60 degrees latitude, both north and south, polar easterlies. The prevailing westerlies, the wind belts found between 30 and 60 degrees, north and south. The trade winds, the winds that blow from 30 degrees latitude almost to the equator, both north and south. The doldrums, those are the trade winds of the northern and southern hemispheres that meet in an area around the equator. Hardly no wind, just dull. And the horse latitudes at 30 degrees north and 30 degrees south, where you have the sinking air creating an area of high pressure. Okay, back to our lesson here. Sorry about that. So let's talk about what causes sea and land breezes. Now, we just spoke about global winds, and that's due to the Coriolis effect, convection, the rising and falling of the wind, cool air, warm air. So now let's deal with local winds for just a second. If you've ever been to the beach, you may have wondered this. So during the day, the air over the ocean is cooler. It's cooled by the water. This forms an area of high pressure. The cool air flows to the land, so it's moving this direction to the land, and it produces this cool sea breeze that you have. So when you're along the coast, you're getting, even though it's hot outside, you're normally getting this cool breeze off of the water due to this high pressure that's being created. So it's not as unpleasant as if you went inland. And then the air over the land during the day is, of course, warmer than it is over the ocean or the water. So as warm air rises, it creates an area of low pressure. And then we have the opposite effect at night. So we start over the land. The land cools down quicker than the water, so the air over the land is cooler. It forms an area of high pressure over the land. And then the cool air moves toward the ocean, producing a land breeze. So now instead of the wind coming from the water like it did in the daytime, it's coming from the opposite direction, from the land. And then at night, the air over the ocean is warmer. So as the warm air rises, it then forms an area of low pressure. So you can see it's just the opposite effect of day and night. So next time you go to the beach, try to pay attention to that. And now you know why in the daytime you've got an ocean breeze and at night you have a land breeze. And this is all due to the local winds and that rising of warm air and sinking of cool air. So local winds, of course, generally move short distances. They can blow from any direction. Mountain and valley breezes are examples of local winds caused by an area's geography, such as here we have the Appalachian mountain chain, so that definitely affects the valley and what winds that we have here. And sea and land breezes are, of course, affected by temperature. Make sure that you go back, log into BrainPop through ClassLink, and watch the video on wind and complete that quiz also. Remember, I'm picking them randomly to include as a grade in Gradebook Wizard. Okay, this is the end of lesson 6.3. Next time, we will talk about air pollution.